Hello everyone. In this lecture, we are going to discuss about the Chomsky classification of formal language. Okay. So before discussing the Chomsky classification of formal languages, uh, we try to understand. Actually, in the previous lecture, I have discussed about there are two classifications of the formal languages. One, we consider whether a language is finite or infinite. Chomsky has given another classification based on the generative power of the formal language. So before moving forward, let's try to solve a question on the previous lecture. So the question is here that you need to determine out of these four given languages whether a language is finite or infinite. So I'm giving you 1 minute to identify. I have given you 5 languages: L1, L2, L3, L4 and L5. So please try to identify which language is finite and which language is infinite. Okay, so you can type your answers in the chat window. Now, what is the definition of finite and infinite language? Finite language will have finite number of strings, and infinite language will have infinite number of strings. So if we talk about the L1 is set of all strings of length 2. So the alphabet is given A comma B. There are two input symbols, and if we try to find out the equivalent set of this according to this definition, so if we want to generate two length string by using small a and small b, we can generate either AA, AB, BA or BB. So only these four strings are possible. That means it is a finite language. So we can say this language is finite language. So L1 is finite. Now what about L2? Set of all strings of length 4. So again, if we want to generate length 4 strings by utilizing A and B symbols, then the total number of strings which we can generate will be 2 to the power 4. So 16 strings. If the total number of strings in this language are finite, then this language is also finite. Okay. Now let's talk about the L3, set of all strings where each string starts with A. So if you try to define the set of this language, maybe we can start with A or AB or AA or AAA or ABA or ABB or any length string. So there is no limit how many number of strings we can generate in this. The total number of strings will be infinite. So this language L3 is a infinite. Okay, because there are infinite number of strings possible. Now if we talk about a to the power n and b to the power n, where n is greater than or equal to 0, it is clearly shows that it can generate null string. So the strings like null we can represent with epsilon. Then we can generate, if n is equal to 1, that means it will generate AB. If n is 2, it will generate AABB. When n is 3, it will generate, and so on. So this is also an infinite language, right? Because there are infinite number of strings possible in this language. Now if we talk about L5, L5 is having only 4 strings, so it is a finite language. Okay, so I hope With this example, you can understand whether a language is finite or infinite. Now, Chomsky has given a different classification that we consider as Chomsky hierarchy or Chomsky classification. So, Chomsky has given there are 4 types of formal languages according to their generative power. So, the very first language the Chomsky has considered as type 0, then type 1, type 2, and type 3. Type 0 type language use unrestricted type of grammar that we will discuss later. Okay, so for this moment, you just try to remember type 0 language use unrestricted grammar, and this language also considered as recursively enumerable language. And to accept or generate this kind of languages, Turing machines are required. So this is a kind of finite state machine only. This Turing machine is also a kind of finite state machine only, right? Then type 1 language, it uses context sensitive grammar. This language is considered as context sensitive language, and such kind of languages can be accepted by linear bounded automata. Okay. Then type 2 languages, they uses context free grammar. That this is very important type of grammar for this subject. We will discuss in detail. And such kind of languages considered as context free languages, and they use push down automata. And then type 3 languages, they use regular grammar, and such language considered as regular, and this is accepted or generated by finite state automata. Okay, so these 4 types of automata you consider: Turing machine, linear bounded, push down, and finite. And there are 4 types of languages: type 0, which considered as recursively enumerable; type 1 considered as context sensitive; type 2 considered as context free; and type 3 considered as regular. In terms of generative power, type 3 is the weakest language. So how do we compare the power of 2 languages? Generally, the power of 2 languages depends on 2 things. The very first thing is, we try to take into the consideration the size of vocabulary of that language. How many legal strings are there or words are there in the language? So if we take the example of, let's say, English language and let's say Hindi language, in English there are less number of vocabulary as compared to Hindi. Okay. And another thing is, we combine the legal words of a language and try to form the sentence. So how many different sentences can be generated by following the grammar of that language is also one of the parameters to decide the power of that language. Okay. So if, let's say, if I say Hindi is more powerful than English, then I need to take these 2 things into the consideration. So if I take an example, let's say a sentence in Hindi, if I try to generate, let's say if I say मक्खी उड़ते उड़ते उड़ गई. So मक्खी उड़ते उड़ते उड़ गई. The sentence doesn't look very weird in the Hindi. It has its own meaning in the Hindi. मक्खी उड़ते उड़ते उड़ गई. But if you want to convert this statement into English, we face a little difficulty to convert this sentence. If I take another sentence, let's say हाथी बैठते बैठते बैठ गया. So हाथी बैठते बैठते बैठ गया, it seems it's okay in Hindi, but when we try to convert in English, it is difficult one, right? So a language is considered powerful if it is having power to generate more number of legal sentences in it. Okay, so the vocabulary and the number of sentences we take into the consideration as the power. So if I am saying here type 3 is the subset of type 2, type 2 is the subset of type 1, and type 1 is the subset of type 0. So that means out of these 4, type 0 is the most powerful language. Type 0, that is using unrestricted grammar, and this language is recursively enumerable language, right? So out of these 4 languages, the type 0 is the most powerful language. Type 0 is the most powerful language. Okay, and then type 1, then type 2, and then type 3. So why this power is we are defining like this? In coming lectures I will elaborate you very clearly how we declare such kind of languages and what type of grammar rules we use. Okay, so please try to remember one more important thing. Regular grammar is accepted by finite automata. Regular grammars are accepted by finite automata. So please do remember, as I have already mentioned here. Context free grammar accepted by push down automata. Context sensitive languages are accepted by linear bounded, and unrestricted grammar or type 0 type of language is accepted by Turing machine only. Okay, so let's talk about formal language in a little detailed manner. A formal language is a collection of strings that adhere to a specific, or you can say specified formation of rules. So these rules will be defined in the grammar. Okay, so a formal language is a collection of strings, or you can say long sentences, and those sentences will be formed by following the rule of grammar. Okay, the Chomsky hierarchy is a classification of formal grammars and languages proposed by Noam Chomsky. Okay, based on their generative power, as I have already told you. So based on the language generative power, Noam Chomsky has classified into 4 different types of languages. It categorizes grammars into 4 types labeled as type 0, type 1, type 2, and type 3, each corresponding to a specific set of rules and constraints. So there are different types of constraints in each type of language. Now let's discuss about type 0 first. So this is considered as unrestricted grammar, recursively enumerable language. These grammar have no restrictions on the production rules. So generally the production rules, as I have already told you, like production rule look like X implies Y kind of thing. So if X can be anything and if Y can be anything, that means there is no restriction in the grammar rules. Such kind of grammar considered as unrestricted grammar. Okay, so this language considered as type 0 and this grammar considered as type 0 grammar. These languages can be recognized by Turing machine, we have already discussed. Some of the programming languages like C++, Java, and Python, they can be considered in this particular category. Okay, then the type 1, context sensitive grammar. So in case of context sensitive grammar, these grammars have production rules with limited context or restrictions. So these restrictions makes this power, I mean, you can say this grammar will allow less number of sentences to be generated because of these restrictions. So this is less powerful than the type 0 grammar. The left hand side of the production rule can have both terminal and non-terminal symbols. It is allowed. The language generated by type 1 grammar are called context sensitive language, that we have already discussed, right? So this is very, very important, context sensitive. And the languages like natural languages like English, certain part of programming languages can also be considered in this particular context sensitive grammar. So in context sensitive grammar, there are some specific types of production rules. Like if I consider there is a production rule like derives phi, let's say here I am taking alpha and here I am taking psi. So here what I am considering is, I am considering this phi is the left context. This is the production rule. Production rule has two sides, left hand side and right hand side. Okay, so in unrestricted grammar there were no restriction at left hand side, there were no restriction at right hand side. Any combination of terminals and non-terminal can occur either of the side. Okay, but in type 1, that is context sensitive, there are two contexts. So I'm taking phi symbol to represent left context. So I'm writing here, let's say this is left context. And let's say I'm taking this psi, which is having right context. These phi and psi can be anything, any combination of terminal and non-terminal symbol. And these two can be null also. Okay. But if any left or right context is active in the production rule at left hand side, that it has to be alive at right hand side also. Okay. So if we take an example, let's say if we are having, A, B, capital A, and let's say B, C, D here derives, then we need to have, if I'm considering AB is my left context, this is representing, let's say phi, then AB has to be alive at right hand side of the production rule also. Okay. And if we are considering, let's say this BCD was the right context, this is the psi, then it has to be alive at this side. So B, C, D need to be there, and this A can be converted into some of the things. So let's say this A we are converting, let's say, into AB. So this A is transforming into AB along with the left context, that is AB, along with the right context, that is BC. So if the context is alive at both the sides, this production rule we consider as context sensitive kind of production rules. So in the context sensitive grammar, such kind of production rules will be there. We will discuss later on in detail. So I hope this can give you a little bit clarity on. Then the next type is context free grammar. So generally we use context free or regular grammar only. Okay. These grammars have production rules where the left hand side is always single non-terminal symbol. So there are less number of restriction at left hand side of the production rule. Only single non-terminal is allowed. Okay. So single non-terminal, let me highlight, please do remember, single non-terminal symbol will occur at left hand side of the production rule in the grammar. Okay. The language generated by type 2 grammar is called context free. These languages can be recognized by push down automata that also we have discussed. An example you can take like HTML or any programming language syntax. Some of the programming language basic syntax they follow generally in this particular context free kind of grammar. Okay. So in context free grammar, if I conclude, left hand side can be a single non-terminal. So let's say I'm considering A as a non-terminal. A can drive, but this side there's no restriction. So it can generate any alpha, and alpha can be any combination of terminal and non-terminal. So this alpha can be any set of terminal and non-terminal up to any length. Okay. So there is no restriction at right hand side, but there has to be single non-terminal at the left hand side. Right. Then the third type of languages that is considered as regular languages, they use regular grammar. Okay. These grammar have production rules with very limited complexity. The right hand side of the production rule can only consist of a single, right hand side can consider either a single terminal or a terminal symbol followed by a single non-terminal symbol. So these two types are allowed. Now if you consider, let's say A is a non-terminal, so left hand side there has to be only single non-terminal that is there. But right hand side there are two things, two restrictions are there. Either it can generate a single terminal, let's say I'm assuming that small a is the terminal, or a single non-terminal at left hand side can also generate a terminal followed by a non-terminal. So these two types of production rules are allowed in regular grammar. Okay. If a language following such kind of grammar, that language we can consider as a regular language. right? Example, regular expressions, finite automaton, or maybe we can use such kind of grammars to do some pattern recognition kind of task. So this is the weakest language. Regular languages are the weakest language, and recursively enumerable languages are the most powerful language, right? Okay, so let's understand the type of the given grammar based on the previous discussion which we had. So I'm giving you one grammar here in which let me define all four tuples of the grammar. So a grammar need to have a set of variables, set of terminals, starting symbols, and production rules. Okay, so set of variables here, if I give you, that is S, A, and B are the set of variables. Set of terminals, there are two only, 0 and 1. Starting symbols I have taken as S, there is only single starting symbol, and the production rules are given these many. So this is P. Okay, so by having all these four tuples to define the grammar, this grammar has been defined. Now we need to identify whether it is, if I give you option, you need to type in the, so it is either type 0, B option is type 1, C option is type 3, type 2, and D option is type 3. Now please type your answer A, B, C, D in the comment section. So if you try to identify the type of grammar, the very first thing you need to identify from the weakest grammar, because every formal grammar, if you consider like type 0, everything comes under type 0 only, recursively enumerable. So it is wise to decide from the weakest point. Now if you try to conclude it as a regular grammar is having only two types of production rules. A non-terminal can drive a terminal, or a non-terminal can drive right hand side a terminal followed by a non-terminal. So if you look at this production rule, if I consider this is a non-terminal, it is driving 1 is a terminal. So this I can conclude as type 3 rule. Type 3 means regular type of grammar rule. This also I can conclude as type 3 rule, because a non-terminal is driving a terminal. This is also a type 3 type of rule. This is also a type 3 type. But there's a problem. Right hand side in these remaining four rules, there are two non-terminals. So B followed by B. This is not allowed in regular grammar, but this is allowed in context free grammar. So in context free grammar, there is only one restriction at the left hand side. There has to be only single non-terminal. So this S is a single non-terminal. That means it falls under the category of T2. T2 means type 2 rule, type 2 grammar, type 2 means context free. This is also T2. Now the point here is, if half of the rules are type 3 and half of the rules are type 2, in which category this grammar we need to claim? So I know that, or we know that now, T3 is the subset of T2. So if we claim this grammar as T2, T3, it will not cover this thing. So we need to claim this grammar as T2. So the answer should be, it is a context free grammar. Okay, it is a context free grammar, right? Now let's identify this grammar. Here I have given you four things. So the set of variable, there is only one variable, that is capital S. The set of terminals 0 and 1. Starting symbol is S, and the production rules are given like this. So S derives 0 followed by S, and S derives 1 followed by S, and S also derives, here it is epsilon. So rather than writing like this, let me update this. We can write S derives epsilon. Okay, now try to identify this. Again the options are same. A is type 0, B is type 1, C is type 2, and D is type 3. You need to type your answer in the comment section. Okay, so I hope you understand the restriction. Again we start checking from type 3, type 2, and so on. So let's check the type 3. If I talk about the very first production rule, there is one non-terminal at the left hand side. So this is allowed in regular grammar. Right hand side, a terminal followed by non-terminal is there, because 0 is terminal and S is non-terminal. That is allowed in type 3. So this production rule, I can say this is type 3. If I talk about this is also in the same category, type 3, because terminal is followed by non-terminal. Now this production rule generate epsilon this side, and epsilon is a kind of terminal. So a non-terminal generates a terminal. This is also allowed in type 3. So in this grammar, all three rules are type 3. That means this will fall in under the category of type 3. That is regular grammar. So this is regular. Oh. Okay, so I'm closing this lecture. I hope the Chomsky hierarchy is clear and you can identify the type of grammar according to the given production. So thank you. See you in the next class.